monopropellant. It's a hydrazine. Okay, and how does the hydrazine get ignited? Where is the oxidizer and where is the fuel?
The fuel is the liquid hydrazine.
Okay.
And the oxidizer is the catalyst bed.
The air.
Catalyst bed and
Catalyst bed. The air, the oxygen from the air.
Yes.
Okay. I mean, your knowledge is very good.
Thank you, sir.
And you have made a very wide selection of all the fuels, all the propellants which you can think of. A good literature survey seems to have gone through it. Very good.
Thank you, sir.
Thank you, judges. Adil, please don't go. Our mentor Kudisa want to comment on your presentation.
Yes, sir.
Adil is known to me. In a public place, I met him when he was in first standard. His mother brought him to me saying that this boy is too crazy about space. So I gave my contact, asked them to contact me, come home and all that. And then his mother came home. The questions he asked, the first standard boy, amazing. I couldn't believe if I had not seen him in front of me. If he was asking from home, I would have believed somebody is prompting him. That kind of questions he asked. Ever since that, he is with us. Thank you.
Thank you, sir.
We talked about Adil more than this. He's a student who won't sleep when there is a SpaceX launch. Even it is at 2 a.m. Clock. He watched it when he was studying in the 4th standard. And he's a person who presented who made a paper presentation in a national webinar on a Children's Day of UL Space Club. Children's Day celebration of UL Space Club. It was our 25th webinar session, and he made the paper presentation for our 25th webinar session in his when he was studying in his 4th standard. So now we have one more UL Space Club participant now here. So it's Krishnendu. She's an active participant of UL Space Club programs. She's an active participant of UL Space Club webinar programs. She participated in almost all sessions of our webinar series, and now she's a member of our student panel group, and she's here with a presentation on life cycle of stars. Krishnendu, over to you.
Good afternoon to all. My name is Krishnendu and I am studying in 10th standard at GVHSS Koilandi. And today my presentation is based on the topic, the life cycle of a star. So, stars. Stars are the most fascinating objects in the night sky, which we are observing from our childhood itself. But the angle at which we are observing the stars changed as we grew up. But still, it's a fascination. So the very basic question, what is a star? A star is an astronomical object comprising a luminous spheroid of plasma held together by its gravity. So, this is the basic definition from Wikipedia. But I would like to define it differently. I am a stargazer, and as a stargazer, I would like to define a star as a very good student in the night sky school who is present in the school in all days, as if in those days when the gate man cloud, who is the villain here, doesn't allow him to the school. So the gate man cloud is the villain here, and this is the present situation. So next we are going to talk about the life cycle of a star. So the life cycle of a star is determined by its mass. The larger its mass, the shorter its life cycle. So you can see two pictures here. This is entirely different from the topic. So these pictures are some nutritious food and some junk food. So I added these pictures in the slide to compare the life cycle of a human with the life cycle of a star. So if you are eating so much mass of junk food and thereby if you are not taking care of our health, obviously our life cycle will be shorter. But at the same time, if you are eating so much less mass of junk food and thereby if you are improving our health, obviously our life cycle will be longer. So in the same way, if the mass of the star is very large, its life cycle will be shorter, And if the mass of the star is very small, its life cycle will be longer. And the mass of the star is determined by the amount of matter that is present in its nebula. It's a cloud of gases and dust. And next we are going to talk about the formation of a star. So the hydrogen gas, which is present in the nebula, is pulled by the gravity and it begins to spin. So obviously when something spins faster, it will get heated. And that's happening here. As it spins faster, it will get heated and it will become a protostar. So now the temperature is increasing, and when the temperature reaches at some point, the nuclear fusion begins and the cloud blows and it begins to contract and it will become stable. Now it has become a main sequence star and it will glow like this for 10 billion to 10 million years depending upon its mass. And this is the stage of our sun right now. And now the star is glowing. The hydrogen in the core of the star gets completely converted into helium and the star stops producing heat from nuclear fusion. So here something is missing. Obviously the star will become unstable. The core of the star begins to contract while the outline of the star begins to expand and it cools down and glows red, and now the star had become a red giant. And the next stage is white dwarf, and this stage is exclusively for less massive stars, and in this stage when the helium gets completely converted into carbon, the core begins to contract again while the outer layer of the star begins to expand, and finally it will be expelled from the star to form a planetary nebula surrounding the core of the star, which had become a white dwarf now. So after some years, when the white dwarf is producing no heat, it will become a black one. And here comes the explosion in the story, the supernova explosion. So this is the death explosion of a star, and this creates lots of light energy and heat energy, which can light up the galaxy for many days. And if the remnants of the supernova explosion is 1.4 to 3 times massive as our sun, it will become a neutron star. So the special fact about the neutron star is that it's the densest astronomical object which can be directly observed by the astronomers. And the next stage is black hole. So a black hole is a region in space from where when light cannot escape, and in this region, matter is compressed into a very small space, and because of this, the gravity is so strong. And you can see a picture here. I am pretty sure that this picture will be very familiar to you because this is the first ever picture of our own Sagittarius A, which is the black hole at the center of our galaxy. And this has become the ultimate image of astrophotography. And this is all about my presentation. Thank you.
Thank you, Shandu. Congratulations on a good presentation. So we would like to move on to judges. So I would like to start from Smita Vitanana.
Hi, Krishna. This is a nice presentation. My slides were also nice. And we tell about one thing. What is Chandrasekhar limit?
And it's the limit to become a black hole. I mean, the decrease number of mass of the sun.
And one more thing is that, one more question about nebula you were saying, no? Once this nebula is there, it's like a gas. Finally, it becomes a disk, right? Disk, and then the center becomes a star. How it becomes? So what's the law which governs this? What is the conservation law? Just think about it. It's actually to conserve the angular momentum because it starts with. So when you make such presentations, so just see what's the physics behind all these also. But once you see this, we start fields and such things, no? Which is, you see the laws of physics that governs these books. So otherwise your presentation was very nice. All the best.
Thank you.
Thank you. Siddhikata sir.
It was a very good presentation. I specifically noticed one thing, your fluency in speaking is very good.
Thank you.
And your voice modulation when you are presenting is excellent.
Thank you.
Because with that, you stress on points, you speak in such a way that the audience gets a lot of information about it. And voice modulation is very good.
Thank you.
And I would say the presentation text was very good, as I see it. The communication skill is very good. And I do not know, the Thomas probably will have look at the time which I didn't notice. I agree with you.
I think you were well within your time of the 10 minutes. Now, everything is good. Whatever both of them told you and all that thing is very good. When you talk of a life cycle, I didn't see the cycle in the slides.
So the limit in the number of slides is 10. So
Oh, that is also there. We didn't know that. But did you exceed 10?
no, sir, exact 10.
Exact 10. But you should have squeezed in that, because that really conveys everything, a life cycle. One would look at the start and end like that. So it could have been the summary slide, Thank you slide you could have dropped and put that figure. Very good. All the best. Okay?
Thank you.
We have one more presentation from R.A. Rush. So,
HDMI ഔട്ടില്ല ഈ സൈഡിൽ നാളെ